with me. Welcome to another class with me. My name is Ming. Today we're going to look at this particular learning target. I'm able to complete the square for a quadratic equation. In here, we will focus on how to do the first equation, y equal to x squared plus bx plus c, where a in this case is assumed to be 1. Next video, we're going to look at when the coefficient of x squared is some real number a instead of just being 1. Okay, let us get started. The idea is actually very simple. Well, in doing expansion, we notice that x plus b, everything squared give me x plus 2bx, right? 2bx plus b squared. Here's the b squared here, all right? And if I have x minus b squared, then what happened is that I can think of this as x plus negative b, such as this, x plus negative b. So then doing the expansion as above, I would obtain x squared plus 2 times negative bx times negative b everything squared. And then by simplification, you will see that, well, the third term b squared always going to have the same sign, that is plus sign. It does not change. It always have the plus sign. Here is also plus sign. The only thing that change is the sign that is related to the coefficient x. So here is plus is related to plus, and here minus is related to minus 2px. That's what we're seeing, all right? Maybe this is not very clear. Let me make this up. Okay, let me put this back. Right, so let me redo this. By mistake, I erased those things. Right, so here is negative b, everything square, plus negative b, everything square, and then here's going to be my x, right? And then this is x squared minus bx plus b squared. Okay, and here there's a 2 here. So what I was pointing at was this. Here I have a negative sign. Here I also have a negative sign. Here I have a plus sign. In front of the 2bx, I also have the plus sign. So now let us look at expansion of another example. So if you have expansion of x plus 1 square, so you're going to get x squared plus 2x plus 1. Now, if you reverse the particular process, that is, if you start with x squared plus 2x plus 1, then we can simply write y is equal to x plus 1, everything squared. This is if you know this to be the result of this particular expansion. All right. What happened if you also have x minus 1 squared? Well, if x minus 1 squared, I get x squared minus 2x plus 1. Reverse that expansion. That is, if I know that I have x squared minus 2x plus 1, then now by completing the square, I should have x minus 1 everything squared, because the expansion of the green will give me x squared minus 2x plus 1. Similarly with x plus 3 everything squared. This is my expansion. So if I know the x squared minus 2x plus 9, right? Then by completing the square, I should get x plus 3 everything squared. Right? This is if we know the quadratic equation to be the perfect expansion of our complete square. This is x plus 3 square or x minus 1 square. This is a complete square. What about this, where we don't really know? So what we do in this case is that, well, what is troubling us is this plus 10. So what we can do is that we consider x squared minus 6x plus 10 equal to 0. Then put the plus 10 to the other side. Basically, we're going to deal with the first two terms, the x squared and the 6x minus 6x. So right now, we going to like completing the square, that is x squared plus, there's always going to be a 2 So you put a 2 outside and the x, and then in the middle must be -3. And the -3 must be square. But if I do this, I'm basically adding 9 square here. But then this equation is no longer balanced. So I have to balance this by -9 square here as well. So the blue and this -3 square cancel out. But the thing in green is a complete square. X minus 3, everything square. So minus the thing in blue. Now I simplify, I get x minus 3, everything square, plus 1 equal to 0. So now I can complete the square by rewriting the x squared minus 6x plus 10, which is the standard form, into this. Well, this, as you can see, is what we call the vertex form now. Right, this is the vertex form. So you may ask, is there a shortcut for this thing? Actually, there is. The shortcut is that for the form of x squared plus bx plus c, we're going to let it equal to 0, like this. Notice the sign. If this is plus, and the next, put a c to the other side. Now the left-hand side is changed into, you use a bracket, x squared, you put in x, plus, you put plus, and then b, because of the 2bx, isn't it? 6 become -3, so it becomes b divided by 2, then everything square. But you need to make sure I balance by this balance negative b square, b over 2 square, all right? Note that the sign in front of the b over 2 everything square is always minus. In this case, it's always minus. Now bring the c back to the left-hand side, and now we simplify, and voila, we finished. So let us look at two quick examples. So if you have x squared minus 5x plus 12, I'm going to rewrite this as, consider this to be equal to 0. Put the plus 12 to the other side, so I consider only the terms with x. So next, this is 5, so I'm going to write x minus 5 over 2 everything square minus, this is always going to be minus, the result of 5 over 2 everything square. All right? And now, you can see that I will expand this, the thing in red, into 25 over 4. Right? 25 over 4. Now, I simplify once more. That is negative 25 over 4 plus 12. And I get 23 over 4. So this is our vertex form. Right? The vertex form is good because it helps us to identify the vertex. For example, in this particular case, the vertex is 5 over 2 as the x coordinate, and the y coordinate is 23 over 4. Right? That is the vertex. Now, similarly, you may want to try this out yourself before you check the answer. So stop the video while you're trying this out. Once you're ready, start the video again to check the answer. Okay, welcome back. Now, let's look. Did you get this step right? Very good. Now, what is the next step? Yes, you put the -1 to the other side. Okay, now what do we do? Right, create the bracket x plus 8 over 2 now, everything square, minus 8 over 2, everything square again, equal to 1. Now simplify, so this becomes x plus 4, everything square, minus 16, equal to 1. Then simplify again, we will get our vertex form. Right? And in this case, it's not being asked, but you can rewrite, you can write that, or you can recognize that the vertex in this case is -4 and -17. All right. Thank you very much, and I hope you have enjoyed the video.